Where's my statement?
And what do we get for y?
41/5.
41 over 5, that seems a little questionable or at least some of you guys said it with a bit of question. Can I get confirmation on 41 over 5?
Yes.
Okay, good. Excuse me. We do get fractions in geometry. In high school, we deal with all the numbers, not just the nice little ones that they always gave you before. So it's okay to get fraction. Now, there are a few different approaches you could take to this. They gave us information about 1, 2, and 3. What do we know about 1 and 2? Supplementary. Good. What do we know about 2 and 3? Supplementary. What do we know about 1 and 3? Congruent. Good. So if you try to do 2 and 3 together and add them up to be 180, you'd run into the issue where you'd have 7x minus 12 plus 5x plus 4 equals 180. You have two variables. So you would need another set of equations. And if you would have done 3 and 1, you'd run into the same issue. So you could have done a system of equations, and that will happen in geometry. For this problem, though, you could avoid it by doing 1 and 2 are supplementary. Then we've got adding these together, so 2x plus 3 plus 7x minus 12 equals 180. And then we solve from there. So you could have done the system of equations, or just, if you were to recognize that, solve for your x, and then you could go back and do your supplementary congruent for solving for your y. There's something else I was going to say with this. Oh, just because they're expressions doesn't automatically mean they're equal. Make sure you look at your situation, decide, is it 180 degrees? Are they equal? Does one equal half the other? Is it complementary? So make sure you think about what you have. Don't just start setting things here. Okay, do we have questions with this? Okay, so let's go and take a look at your homework or proofs. And again, today it's just more proofs and quiz. So the quiz is only 20 minutes. So we'll just do practice until 20 minutes before the end of class, and we'll do a quiz. Homework, that's what we said.
What are all the properties that we need to have here? This is second edition.
Everything. But in terms of the algebraic properties, we don't use the identity and inverses very often. And that we use the other ones. Okay. That was my... Alright, so we talked about this last class, our differences between our definitions and our theorems postulates. But again, this is probably the most common thing people mix up on their theorems or on their proofs, aside from just straight up not knowing your vocab. So I just want to reiterate the differences between our definitions and our postulates theorems. So when it comes to the world of linear pair, supplementary, and all that jazz, linear pair definition just lets me identify, look at the picture and say 1 and 2 are a linear pair. Once I have it's a linear pair, then I can say by the linear pair postulate, 1 and 2 are supplementary. Then once I have their supplementary, I can say by definition of supplementary, they have to be 180 degrees. So notice each one's responsible for a different thing. Linear pair definition lets me say they're linear pair. Linear pair postulate lets me say linear pairs are supplementary. And definition supplementary says supplementary angles have to be 180 degrees. So a lot of times you have to use 2 to 3 of those in order to get it from linear pairs to the 180 degrees. For vertical angles, our definition just lets me simply say 1 and 2 are vertical angles. It's the theorem that lets me say vertical angles are congruent. And again, if you forget the titles, that's fine. You can just write on what it says. These beginning ones are pretty short in what they say. And then suppose I want to say, instead of angle 1 and 2 being congruent, maybe I need to say measure of angle 1 equals the measure of angle 2. When I go back and forth between congruencies and equals, measures equal, angles congruent, that's our definition of congruent, and then whatever we're talking about, congruent segments or congruent angles. And then last but certainly not least, because we use it a lot, especially in Unit 1, our segment addition postulate or angle addition postulate. We have pieces add to be the whole thing, pieces add to be the whole thing. And just a reminder, so for segment addition postulate, and it's true also for angle addition postulate, we typically will write it like this, where we say piece plus piece equals the whole. But on occasion, sometimes they'll do it where they say our piece, AB, equals the whole thing minus this chunk that we didn't want. So we still call this segment addition postulate. It's technically segment addition postulate with a step of subtraction though. But I've seen where they just throw it in like that. So that's still segment addition postulate. Not segment subtraction, it's just a variation segment addition postulate. And just a reminder, these have to be collinear, these have to be adjacent. So we went over that last class, but just to refresh it, because those are the common mistakes people make. All right, so let's go ahead and we'll probably just take a look at one proof, and I'm not gonna, you're welcome to write it down if you want to. You don't have to, but I'm just gonna have you kind of look at it, brainstorm with your shoulder partner, and then we'll come back together and take a look at it. And I think the one I want is this guy. Let me zoom in for you guys. So again, you don't have to draw this if you don't want to. I just want you to discuss with your shoulder partner, how would you go about solving this proof? Take it away. And then we'll come back together and go over it. Have proofs on it? I mean, it's your proof quiz. There are infinite possibilities for proofs.
I just have no I knew that your butt was starting. That's why I was laughing. Wait, what did you say? How did you put
All right, let's go ahead and take a look at this together. Real quick, I know we're just talking about it, but real quick, try to approximate how many steps do you think it would have taken here?
Four.
Okay, hopefully not 2. 3 to 4 sounds a little better. We should never have we should never have a 2-step proof. Don't forget there's the given. Okay. So let's take a look at this. It might be a little longer than you think, simply because what does the vertical angle theorem tell us? Vertical angles are congruent. Good. Do we have congruent though? No, we've got measures equal. So that means we're going to have to do some translating back and forth. That might lengthen it a little bit. Okay, so they gave us measure of angle 5 equals the measure of angle 2. Okay, so that would be our given. I'm not going to write it out. I'm just going to keep track of how many steps here. And then what else do you guys know? What were you guys saying with your shoulder partner? What do we know? Joseph? Good. And how do we know 2 and 4 are congruent? Good. Vertical angle theorem. And would you guys agree we would need to say that also for 5 and 8? Yes. Awesome.
So when we make that one step?
You can put it, since you're doing the same thing, you can put it in the same step. If you listen separately, that's fine. Okay. Now, we said they're congruent, but we're talking about measures here, so we would probably need that step of translating it, right? What do we call that when we switch it? Good definition, congruent. All right, so we've got 3 statements here. We've got 2 and 5 measures are equal, 5 and 8 measures are equal, 2 and 4 measures are equal. So then how do I get to measure of angle 8 equals measure of angle 4? The next one? Use the transitive. Yeah, we use the transitive property, and we actually get to go kind of a long way with it. So we have 2 and 5 are congruent. We're trying to show 4 and 8 are congruent. So we essentially are doing transitive property where we're replacing 5 and 8, and transitive property where we're replacing 2 and 4. So 8 is equal to 5, which is equal to 2, which is equal to 4, or vice versa. Okay, so we would have our transitive property. So yeah, of course, absolutely. Even with transitive.
And then we have to do one more step to transform it back to measures, because
Well, so with our vertical, you can go either way. But what I would do is after we do vertical angles, there, just translate that to measures. So you could either take your given and convert it into congruency, do vertical angles there, and then at the end convert to measures, or take your vertical angles there and convert that to measures, and then you just have measures for the rest of the thing. So it's up to you either way. So this is actually something we're going to be learning next unit with our parallel and perpendicular lines. 2 and 5 are called corresponding angles, and our corresponding angles class that tells us that those are congruent. 2 and 8, 4 and 8 are also corresponding. 2 and 8 are alternate exterior angles, which we're going to learn are congruent as well. But that's from later. Flora, do you have a question?
Yeah, don't we need to say that, like, to our first?
Oh, that is a good question. So yes, in our unit 1, we would first state that they are vertical angles. Yeah, so that would actually put on a step 5. Once we get past this unit, then I go a little nicer, and you guys don't have to identify them as such first. But yes, we do technically need to say 2 and 4 are vertical angles, 5 and 8 are vertical angles before we say vertical angles there. That's very good. And what lets me identify them as vertical angles? Definition of vertical angles. Okay. So we'll just go and transition to our quiz now. Once you're done with your quiz and you turn it in, I'll put the homework over there. You can pick up the homework with this work on that. You are welcome. Yes. So the only thing is that each row stays for you. So you can put it wherever you want. Sometimes you don't use it right. I'm sure you've stated it before. You don't have to remember either. So, yeah, you can connect to the computer and see and then that's fine. Quizzes, that's what you So again, once you're done with your quizzes, then you'll just pick up your homework, which is worksheet 7, which is just more practice with proofs.